Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and the concepts for our upcoming CSIR net and the GATE physics exam. So I hope that the discussion which we will be doing today in the session will be getting clear to all of you. But in case if anywhere you will be having any doubt, you can let me know about it. Give me a second. Okay, so initially what I'm gonna do, I'm just gonna tell you something related to the Unacademy subscription and the latest offer or anything new, and then we will go ahead with the discussion. Okay, so actually, guys, if I'm gonna talk about this one, so this is regarding the 7-day free trial, how you can take these steps and you can start your 7-day free trial. So actually the step number one is you have to enter your phone number, and then next thing you have to do is to verify your OTP. Next, you have to select your target exam like CSIR UGC net. Next, you have to enter the activation code, and then you can download the app to start your preparation. So this is how, by following all these steps, you will be able to get your 7-day free trial. Now we will start the discussion about the other important points like this one. If anybody is there who wants to take their preparation to the next level and want to like join the sessions of the well structured and well planned courses by the top educators, then guys, you can take your Unacademy plus Iconic or the Iconic subscription or the plus subscription. And whenever you will go ahead to take the subscription, you can also use and apply the code Anjali A Live as mentioned here on the screen. Okay, so by using and by applying this code, you will be able to get the discount in the total subscription amount. Even now the important notes are available on the learning app too, guys, so which will be helping you to take your preparation to a very good level. I'm going to continue that discussion. Okay, so basically, the first line I'm showing you right now is regarding the Unacademy Learning app. This is something about the session. This is something about me. Here we are gonna have the information about the community feature, which will be helping you to stay updated and to know about the latest updates and the information. So this is how, guys, everything will be helping you a lot to take your preparation to the next level and even to stay updated. Also, guys, if I'm going to talk about the next thing here, that is, since in this session we are going to take the mathematical physics discussion, so I'm going to start the discussion with some of the important questions, and I'll keep on taking the questions from different topics, whichever are most expected one, okay, in your upcoming exam, or from which topics there are great questions, like so many questions we got in the previous years. So all that I'll consider. Okay, guys, let's start with the first question in the session. And anywhere, if you will be having any doubt, you can surely mention it and let me know about it, that something is not getting clear to you. Okay, you can mention it in the comments. So let's start the discussion with our first question. This is simplifies to, where I in the options is the 3 by 3 identity matrix. Three cube m, and option D says e to the power m equal to e minus 1 and m. Try it now, guys, and if something will not be clear to you, you can tell me. I'll try to make it clear, or I'll be explaining it then. Okay, hello Rima. Try it, guys, and let me know wherever you will have any doubt. Otherwise, in just some time, I'll start the discussion. Okay, or before that, if you will get it, tell me what is the right answer according to you. E to the power m, like you can either have a look at the options or the given matrix is there, or think how many different ways you have to find it. Okay, because it will be in general, you have to think about for this question. There is not a one fixed rule. Maybe next time they will change your options, the way they are going to represent it. Accordingly, you have to take the steps, or you have to decide what can be done. But I would say try to get some idea from the options and the given metrics. Otherwise, I'm going to start the discussion soon. Okay, I'll be sharing all the details and everything, but I want you to even consider it first. See how many things you know about e to the power m. How many different ways are there to expand it, to write it. So this is exponential, right? We know exponential series expansion, right? So that's the one thing you know. And is there any other choice you have you can work with? I think not really. That is the most popular thing we all know about. So let's just start with the exponential series expansion, which is e to the power m is equal to 1, or since m is representing the matrix, I can write it as I plus m square over factorial 2 plus m cube over factorial 3, and so on to. Depending on the matrix which is given to you and having all the elements equal to 1, so m square is equal to what? If you will multiply the given matrix m with itself, you will find it's giving you all the elements equal to 3, 3, 3, 3, 3, which is going to be giving you 3 common and 3 times the m. When you will write 3m cube, so m cube means m square times m, which is going to be 3m times m, right? So again 3m square again can be written as 3m, so which is giving you 3 square m, right? So I can replace m square with 3m, m cube with the 3 square m. We will be considering it whether it is correct or not. Look at option B. It's not showing you so on to part, means it can have so many other terms too. No, it is just saying the 3 terms should be there. So are you getting just 3 terms? I think your answer should be no. You are gonna say no, you just don't have the 3 terms, you will have further terms too. So that's the reason your option B cannot be correct one. Okay, now next thing, once we observe this part, what next? Next is we are just going to simplify these things, like 3m divided by factorial 2 plus 3 square m divided by factorial 3 and so on too. So when you will take the m common, you are gonna have 1 plus 3 over factorial 2 plus 3 square over factorial 3 and so on too. Now we can see it's not matching with any of the options. So what I should do, I can see e cube is written there. Maybe I will be able to form the e to the power 3 exponential to the power 3 series. But for that, I'll multiply this expression with 3 and divide by 3. So when I'm dividing by 3 and multiplying with 3, I'm gonna have this. But to make it exponential series expansion, I also need 1. So 1 I will add and I'll subtract from the series. So 1 plus of this whole thing will give me e to the power 3 series, and minus 1 is extra. So m over 3 e to the power 3 minus 1, that's what we are going to get. So I plus m over 3 e cube minus 1. So that's how you got your right answer to be option A. Please let me know, is that clear to everyone or not? So your option A will be the correct one. Is that okay and clear? Look at the steps, look at what we have done, how we use the metrics, how we just considered these conditions, like what we will get, and then finalize your answer. Is that clear, guys? Great. I'll give you the next question then. Minus y cube. Try it now and let me know what do you think is the right answer. Excuse me. Waiting for your reply, guys. What is the right answer according to you? You can just mention it. Otherwise, I'm gonna start the discussion too. So, actually, in this case, what's gonna happen? You just need to check out which one of the following cannot be the real part of the complex analytic function. So, here we know that for any complex analytic function, its real and imaginary parts should satisfy the harmonic function condition. Now, what is that condition? That condition is whether you take the real part u or you take the imaginary part. Okay, so it should satisfy the condition. Very good, Satish. That's great. Delta to u over delta x square plus delta to u over delta y square must be equal to 0. Same way for the v, you can check out this condition. It must be 0. If any of these options doesn't satisfy this condition, means that cannot be the real part or the imaginary part of any analytic function. So that is option A. If you will plug it in at place of u, you will find it's not giving you the value 0, hence it is not possible. Okay, so that's correct. Now let's go for the next question, guys. Next question is this: consider n to degenerate eigenvalues with degeneracies to end Try it now and let me know what do you think is the right answer according to you guys. Waiting for your reply. Waiting for your reply, guys. Whatever is the right answer according to you, just mention that. Option D. Okay, let's talk about it. So basically, before going ahead with this question's answer, I would like to tell you one thing here. That is, if there is a square matrix whose rows and columns are the scalar multiple of a particular row and a particular column, in that case, what we will say is like the both conditions should get satisfied. The rows and the columns of the square matrix should be the scalar multiple of a particular row and the particular column, right? So if you will see the type of matrix I have written, if you multiply the first column with 2, or if you multiply the first column with 3, you are going to get the second and the third column, right? Same way if you will do for the first row and the third row, so you are going to get the same thing there. In that case, you are going to have the eigenvalues equal to what? The trace comma 0 comma 0. So it's going to be 14 comma 0 comma 0. Okay. Now, in this case, since it was 3 by 3 order matrix, we are going to have the 3 eigenvalues. So one is non-degenerate one, means it's not repeated. It's not present again and again. But 2 are degenerate. And the degeneracy is what? Equal to 3 minus 1, which is equal to 2. So only one non-zero eigenvalue, rest you will have 0, 0, right? So one degenerate eigenvalue with degeneracy 2 and one non-degenerate eigenvalue. Let's have a look at this. Has one degenerate eigenvalue with degeneracy n minus 1. In our case, we have taken 3 by 3 order matrix, so we were getting its degeneracy to be 2, which is equal to n minus 1. Does it make sense? The second option is saying has 2 degenerate eigenvalues with degeneracy 2 and n minus 2, which is wrong. Has one degenerate eigenvalue with degeneracy n? No. Does not have any degenerate eigenvalue, it's even wrong. So did you get that? So 2 by 2 cannot make it clear to you, because in 2 by 2, if you got 1 and 1, okay, you will not get, like even if one non-degenerate, you will not get the clarity about it. In this situation, you also have to go for 3 by 3. 2 by 2 is not going to make the things clear to you, right? Because degeneracy possibility is less. So that's not the right thing to consider here. At least 3 by 3 you have to check. In 2 by 2, if you are getting just 2 eigenvalues and both are different, so you can't define degeneracy. In 2 by 2, there will be exception. Why? Because either both should be same, then only you can describe the degeneracy. Otherwise, if one of them is different, other one is different, you are not able to describe it, right? So you have to check out the 3 by 3 to have the clarity about this part. Okay. Let me just give you the next one then. Try it now and let me know as you will get it done. Satish, if you will by chance have 5 by 5, whether I can tell you in CSR net, in GATE, in JEST, in TFR, rarely you will have any time you got the 5 by 5 order matrix. But if in case you will even get it, either that will be related to the condition we talked about, that the scalar multiple part. So you have the trick to write its eigenvalues. Either all of them can be equal, or if it will be a diagonal matrix, then you know that its eigenvalues are equal to the principal diagonal elements. So some condition based questions you may have, which you can answer without solving it completely. So that is possible, but other than that, like solving it with the detailed approach, I think that's rare. You may even not have find it out anywhere. If it is there, great chances there is some trick, some short way, some direct way to solve it. But what they asked, did they ask to simplify to find its determinant and all, or did they just ask the rank? Because as I am telling you, if they will ask, there will be some short trick. There will be something like you can answer it directly. It can be a kind of diagonal matrix, the upper triangular matrix. It can be a matrix having its rows and columns as a scalar multiple of each other. It can have the matrix having all the elements equal to each other. It can be like any such thing that should not take too much time. Okay. So check it once and see what it is exactly. Or in net and get, like in just you get quite lengthy questions, right? Maybe they can even give you then, but in more previous years, if you will check, it was not there. And also check out what they exactly ask you to find. So that may make it clear to you that are you having some trick associated with it? Is there something which can help you to answer it directly or not? Okay. Like there are ways to solve them, but the main point is what you want to find. Clear? Are you talking about determinant? Are you talking about eigenvalues or what? Or the second thing is that even to find the determinant of higher order matrix, there is a way, but it is time taking, right? In comparison to 3 by 3, if you go for finding determinant for 5 by 5 or 4 by 4, for the detailed approach method, it's time taking. So that's what you have to consider. Here is the question, guys. Yeah. Tell me whatever will be the right answer according to you. I'm waiting for your reply. Yeah, that's correct. But how you will get it, let's quickly talk about that part. So actually when mod z is equal to c means, is equal to 1 over 2 means it's having a circle, having its center at the origin and its radius is 1 over 2, right? So in that situation, what will happen? If you're going to consider this part, you are going to get it easily that you are not able to get, see, there are different ways of finding the residue. One is depending on the order. If it is the order 1 pole, then your residue formula is limit z tends to az minus afz, right? The second one, for the first order pole itself, that is numerator as it is first order derivative of the denominator, and that way you can consider, right? Third thing is the higher order pole, like here you will have order 2. So there are two methods, with one of them is applicable for simple pole or order n pole. The method I will be considering here is, if z is equal to a is a pole, it can be order n or it can be order 1, right? In that case, let z minus a is equal to t, and the coefficient of 1 over t gives you the residue. Do you know about this method of finding residue? So a is the pole and z minus a, you consider it as t, and the coefficient of 1 over t is representing the residue. So here what is the pole? The pole will be z is equal to 0. That is lying within the contour, because only 0 is lying within the contour, right? And sine 0 is what? 0, and 1 over 0 is what? Infinity. So z is equal to 0 is a pole, order 2 pole. Next thing, now if I am considering z minus 0 is equal to t, then can you get the coefficient of, because z and t are equal this way, right? Because 0 we had there. So coefficient of 1 over z only or 1 over t, can you get in this case? The answer is no. Reason, if you will even write the sin z series expansion, it will have the overall square term there on top. So if you will even try to take the z common, you will have the z square outside. You can't have just z, which means the coefficient of 1 over z here will be 0. So residue is what? 0. So final integration is what? 2 pi iota into sum of residue, which is 0, and that's how you are going to get just 0 here. Please tell me, is that clear? You can't get the coefficient of 1 over t, which is 0, because the term is not present. Hence 2 pi iota into sum of residue gives you 0. If you still have any doubt, just let me know. And if it's clear, I'll give you the next question. These are ideas. Okay, maybe somebody who is just starting to work on contour integration cannot relate it directly. But as you have worked on this question now and you can find any such point in other questions, you can catch it soon. You can get to know like, oh yeah, this is the point I can relate and I can check out. Here is the next question, guys. If you still have doubt, tell me. And it's important to work on the questions, to solve as many number of questions as you can, because they give you ideas. And even if you will be doing any question for the first time later on, anytime, these ideas are going to help you to solve those new questions, different questions. Okay, that's the importance of working on many questions, or even by repeating them, those ideas become strong. Clear? If you have done it just once, that is like quite okay, you may forget about it later on, but when you just keep on considering and keep on working on it, so those ideas will become more stronger, and your chances of relating it with the different questions will be increasing. Try it now. Let me just see if you can read the last line or no. Whatever is the right answer according to you guys, you can mention it. Yeah, I think it's visible. Waiting for your reply, guys. As you will get it done, let me know. I'm waiting for your reply. Very good, Satish. Option B is the correct one. So here, since they have given the simultaneous eigenvector, so we know that for the eigenvector, like we are having characteristic equation for the eigenvalues, which is like a minus lambda I is equal to 0, right? This helps us to work on the eigenvalues. But if I will talk about eigenvectors, so we just make this equation as a minus lambda I times x is equal to 0, where x is eigenvector. You can also modify this equation like this. So here we will use this one finally, ax lambda ax and bx lambda bx, depending on what eigenvalues or eigenvector they are talking about. Corresponding eigenvectors you have to take there. If it is simultaneous, means same. You will form the equations from here. You will form the equations from here. They can help you to get the relation between B and A then. So that's the process you have to follow, and it will give you the option B to be the correct one. That's right. Let me just add the next question. The principal value of the integral, which is negative infinity to positive infinity sine 2x over x cube dx. So your options are negative 2 pi, negative pi, pi, and 2 pi. Consider it and let me know whatever will be the right answer according to you. Waiting for your reply, guys, and we'll be starting the discussion soon. Are you getting option A? And that's correct too. Very good. Few points I would like to mention here. The first thing is integration minus infinity to plus infinity. Whenever you will have, you are just supposed to take the purely real axis pole, okay, the poles lying on the purely real axis or in the upper half of the complex plane, either here purely real axis or in the upper half of the complex plane. Whenever your pole will be purely real, you will just take pi iota into sum of residue corresponding to the purely real pole, okay. And if it will be imaginary, complex number, something like that other than purely real pole, then 2 pi iota into sum of residue, okay, other cases. And another thing is, like, you have the sine or cos present here, so you will write it as, e to the power iota theta is equal to cos theta plus iota sine theta. So cos is what? The real part, and sine is what? Imaginary part. So whenever sine is there, you will say imaginary part of integration and all of that, okay. This is how you will be able to consider it. Please tell me, are you familiar with these points? If yes, I think it's gonna be quite easy for you to find the answer for any such type of question. Then I'm gonna give you the next one, guys. I think just two more, maximum two questions we can take now in the remaining time. Try it now and let me know if in case there is any doubt or difficulty. Very good, Satish. That's great because you know that we cannot have the imaginary part alone. It should have the complex conjugate term present along with it for the real matrix. Okay, in case of its eigenvalues. So in option D, we just have iota but not its complex conjugate term present there. Hence, that's not possible. Okay. In other cases, if you will see all the eigenvalues are purely real, or if there is imaginary, its complex conjugate is also given. So all other options will be correct, but just the option D, which is having alone imaginary term present, cannot be correct. Okay, let me just give you the next one. I'll write the options here. Try it now, guys, and let me know as you will get it done. What is the right answer? That was correct, Satish, for the previous question. Once you will get it, just mention it in the comments. What is the right answer according to you? Very good, Kartika. That's correct. Or very good, Satish. That's correct. So actually, in this case, what we will do, one, we know we can write it as P naught x. We can just replace it. Then you know x can be written as P1x, and then 3x square can be written as 2 times P2x, and plus 1 will be there. Okay, and then 2 times p2x plus 1 plus 1. 1 can be written as p naught x again. So that will give you 2 p naught x. And you know that you can write the function as summation over n, cn, pn. So c naught p naught plus c1 p1 plus c2 p2. So c naught p naught, whatever is along with p naught, it's c naught, which is 2. Hence your right answer is option C. Please tell me if in case there is anybody having any doubt, we can talk about it, or every question we have discussed in today's session. Guys, if something is not clear, you can tell me. I'll try to consider that part. Let me just see if it is possible to take one more question, or otherwise we will be ending this session. Okay, let's take one from differential equation before ending this session. In terms of arbitrary constants A and B, the general solution to the differential equation that's x square d2y by dx square plus 5x dy by dx plus 3y is equal to 0. Options are y is equal to a over x plus bx cube, b is equal to, b says y is equal to ax plus b over x cube, c says y is equal to ax plus bx cube, d is y is equal to a over x plus b over x cube. Try it now and let me know as you will get it done what is the right answer according to you. This will be the last question for the session, guys. So firstly, for the differential equation, it is important to identify what kind of differential equation it is. So if you will consider its Cauchy-Euler differential equation as the power of x and the order of differentiation, they are going to be same. So in this case, x square d2y by dx square can be replaced with d times d minus 1. And x dy by dx can be written as plus 5 dy, okay, plus 3y is equal to 0. If you will simplify it, you will get a quadratic equation in terms of d. Here basically d is nothing but d over dz, and z is equal to e to the power, like x is equal to e to the power z. Z is a third variable, right? It's not there. So z is equal to log x you will have. So you just have to write it this way. Your final solution must be in terms of, Satish, check it out. Is it b or is it d according to you? So we are going to get d square plus 4d plus 3 equal to 0 as the quadratic equation. It will give us the d values to be 1 and I think negative 3, right? So 1 and negative 3, or negative 1 and negative 3. So now when you will write its solution, it will be simply giving you y is equal to c1 e to the power m1 z plus c2 e to the power m2 z. So you got negative 1z and negative 3z. So z is equal to log x. Write it in the power. It will give you c1 x to the power negative 1 plus c2 e to the x to the power negative 3. Because log x will be here, negative 1 will go on the power of it as per the logarithmic property, and log m is equal to log m to the power n, right? So that's giving you, since exponential and the log base will be same, so they got simplified. This is how your option D is correct. Very good, Satish. So let's keep it this much right now in the session, guys. We will have one more session tomorrow early morning. I think its time is 7 o'clock. You can even see if you can join that. It will be here, okay, on Unacademy Live CSIR UGC net. So let's keep it this much right now in this session, guys. Thank you so much everyone for joining this session and for attending it till the end. I hope everything we have talked about today in the session is getting clear to everyone. But if you will have any questions or queries, you can surely let me know about it. If there is anyone who wants to take their preparation to the next level and want to do the best preparation under the guidance of top educators, then you can take your Unacademy Plus Iconic or the Lite subscription. Use and apply the code Anjali A Live to get the discount in the total subscription amount. Thank you so much everyone for joining this session and for attending it till the end. Thank you. Bye. Take care. See you in the next session, guys. So yeah, tomorrow early morning we will have a session here, and same way our plus course class timings, like as they are going on right now, they will be there. Okay. Thank you everyone.